So this is the first lesson in our function unit, and our learning target is I can determine if a relation is a function. And I'm going to tell you what each of those words means. It should be from previous math courses, but sometimes we forget, so hopefully jog your memory. All right, so a relation is what you've looked at usually, I don't know what happened there. Usually in like some lower math courses, a relation is just a set of coordinate points, so those x, y coordinate points. And then sometimes they call those inputs and outputs. So inputs are the x's and outputs are the y's. So if you look at the example, you have 3 different points. We have 2, 3, 3, 5, and 4, 7. So anytime you've heard inputs before, those are your x coordinates. All right, and that's why your inputs are 2, 3, and 4. And then in green, I'm going to do your outputs. Those are your y coordinates. So 3, 5, and 7. So that shouldn't be new information. You should already know what a relation is and how to graph those. But this is just to jog your memory. So now we're going to move on. So I'm going to just make sure you know how to graph a relation because it's very important. We'll be doing this all year round. Okay, so first thing, we have 4 points that we're going to graph. We're going to graph 1, negative 3. We're going to graph 3, 0, 4, negative 2, and 5, 4. Okay, so I color-coded those. I put the x coordinates in blue and the y coordinates in red. So if you'll remember, the first thing you're going to graph is your x coordinate, and you're going to look at your x-axis. So right here is your x-axis. And my first x coordinate is 1, so I'm going to start over here at 1. Okay, and then my y coordinate is negative 3, so I'm going to find negative 3. So I'm going to take that 1 and I'm going to go down to negative 3. So that is the point 1, negative 3. And then in this class, I'm going to tell you to like label things. So if you'll just put, I'm not really sure where to write it, I'm going to put a 1, negative 3. So that red dot stands for 1, negative 3. All right, so next one, I'm going to do this one in blue. I'm going to start on the x-axis at 3, but I'm not going to move up or down because I'm on the y-axis at 0. So there is that point. And I'm going to label that one 3, 0. Okay, next one I'm going to do in green. So 4, negative 2. I'm going to find 4 on the x-axis, and then I'm going to go down to negative 2 on the y-axis. And I'm going to label that one 4, negative 2. And then my last coordinate point, let's do that one in purple. All right, purple, 5, 4. So I'm going to go over to 5 on the x-axis, up to 4 on the y-axis. So here is that point. And I'm going to label it 5, 4. So very important when you're doing these, make sure that you're plotting points correctly. Make sure that if I tell you to label something, you're actually doing it, because I'm not doing it just because I'm a sadist and I'm just trying to inflict pain. I'm doing it to help you, I promise. Just trust me. Okay, so that's how we graph relations. All right. I don't know why the computer's doing this, but here we go. So the next thing is a function, which you've probably talked about in previous math courses. But just to jog your memory, a function is a type of relation that for each input there is only one output. So there's some different things we've done with functions before. This phrase is probably new for you, but I want you to get used to this. For every x, there is one y. So that for every x coordinate, you only have one y coordinate. So like if you had an x coordinate of 3 and a y coordinate of 4, then if you had another x coordinate of 3, it couldn't be another number, because for every x coordinate, there is only one y coordinate. So when x is 3, y can only be 4. If you had another point like this, that would not be a function, because you're saying when x is 3, y can only be 4. For every x, there is only one y. And we'll look at what that looks like in different situations. Okay, so here's an example of a function. So here's something else I've done, just because we are moving up to Math 3. Up until now, we've usually done x, y coordinates. But I want you to get used to seeing this function notation f of x, which means the same thing as y. It just means a function of x. So that's why it says f of x. So anytime you see f of x, it's the same thing as y in previous math courses, but the higher up in math you go, the more you're going to see that f of x. So just think of that as y. Okay, so same thing. I'm going to go ahead and I'm going to pause. So I'm going to count to 3, and then I want you to see if you can graph these. Just make sure we got this. So I'm going to pause the computer in 1, 2, 3. Okay, so if you graph that correctly, it should look like this. So usually, you know, we're going to connect these points, and then we would have a function that keeps going. But unless I say to connect the points, you don't have to unless you're just used to doing that. So just another thing to keep in mind. Just dots are okay for right now. Okay, so here's an example of a non-function. So over here on this page, we had a function. I made it look really ugly, sorry. And now I'm going to show you an example of a non-function. So I'm going to go ahead and pause it and let you plot them, and then we'll talk about why it is not a function. Okay, so this graph paper on here is throwing me off a little bit, but this is what it should look like. So why is this one not a function? If you will notice, if you look at these two coordinate points, when x is 1, y is 2, and it's also negative 2. So for every x, there is not one y coordinate. And then also the same thing down here, 3, 5, and 3, negative 5. For every x, there's not just one y coordinate that corresponds to it. So that makes it not a function. It's a little hard to grasp. We're going to do some more examples. Okay, so let's look at what it looks like when it's a function and what it's not a function. So this may be something that you've heard of in the past, the vertical line test. To use the vertical line test, you're going to take a ruler and draw a vertical line. That's an up and down line because you don't know what vertical means. If the vertical line intersects the graph more than once, the graph is not a function. So the bottom one is a function because if I drew a straight up and down line, I know these are not straight, I'm not using a ruler, it's only going to touch the graph one time. But look at the top one. If I were to draw a straight line right there, it hits 3 times. If it hits more than once, it is not a function. So that's how you can just look at a graph and tell if it's a function. Okay, so here's what I want you to do. I want you to sort these examples into 2 categories. They either are a function or not a function. So what you have is you have like these 3 right here. These are just some coordinate points. Tell me which 2 are functions and which 2 are not functions. And then you have in red over here you got some tables. So there are 6 tables to look at. 3 of them are going to be functions. 3 of them are not going to be functions. You got some graphs right here. 2 of them are going to be functions. 2 of them are not going to be functions. And then I think, for me, I think this one's the hardest one. These you probably saw in middle school. But I want you to see if you can figure out, it's just looking at inputs and outputs, which one is a function and which one is not a function. So take a piece of paper and sort these into 2 categories. Okay, if you need more time, then pause it and take more time. I'm going to show you the answers. Alright, so if you'll look right here, I tried to divide these into 2 categories. Here are my functions. And then here are my not functions. So the two relations at the top, these are functions because for every x value, there's only one y value. If you look at the not functions, notice 1, 4 and 1, 2. When x is 1, y is 4, and it's 2. So it can't be a function because for every x, there has to be only one y. Same thing with this one. If you look at 5, 1, and 5, 3, you have an x value of 5, but you have a y coordinate of 1 and 3. That can't happen. All right, and then if you look at the tables next, right here. When x is 4, y is 3, and y is 2, that cannot happen. When x is 3, y is -1 and 0, that can't happen. And then this one's a whole lot of mess. When x is -1, y is 3, 4, -2, 2, and 0. Can't happen. Okay, and then for the graphs, you can just do the vertical line test. If I draw a vertical line test on the circle graph, it definitely hits twice, not a function. If I draw a line on the S-looking graph, it hits 3 times, it's not a function. And then if you look at the input-output charts, if you focus on the -2, when x is -2, y is -1. When x is -2, y is 8. So remember, in order to be a function, there has to be, for every x value, there is only one y value. That's what you're looking for. So you can look at it in relations, you can look at it in tables, you can look at it in the input-output, or I think the easiest way is to just look at a graph. Okay, so now we're going to go on to evaluating functions. So this is probably new for you. So I tried to color code it a little bit. We have 6 different points we're looking at. Is that right? Yes, 6 different points. All right, so that first point, the -4, 5, this is saying if I evaluate the function at -4, it's going to equal 5, because that's what exactly that point says. If I do this next one, -2, 3, it's saying if I evaluate the function at -2, it's going to be 3. The next one in green, if I evaluate the function at 0, it's going to be 1. If I evaluate the function at 2, it's going to be 0. If I evaluate the function at 3, it's going to be -1. If I evaluate the function at 4, it's going to be -2. Anytime you are talking about these values right here inside of parentheses, these are always x coordinates. And anything that equals by themselves are your y coordinates. So that's something to just get used to. Okay, so we're going to do this quickly. All right, so I have a function f of x at the top. It says 5x plus 2. I'm saying that my x's can be -2, -1, 0, 1, or 2. My rule is what I'm evaluating it for. So 5x plus 2. If I want to find f of x, I'm going to plug in this value for x. So if I plug in 5 parentheses 2 plus 2, oh, that's a negative, my bad. I'm evaluating that x for -2. I'm replacing that x with a -2. So if you do that, you get -8, which means the ordered pair would be -2, the thing we evaluated it for x, and then the answer we got, -8. See if that makes sense for this one. So my rule is still 5x plus 2. I'm now going to evaluate the function for -1, which means my x is -1. So I'm going to replace x with -1, and I'm going to see what I get. When I do that, I get -3. That means my answer is -1, -3, because I got inputs and outputs. Okay, I'm going to do the next one, and I'm going to let you do it. So my rule is 5x plus 2. My x coordinate is 0. I'm evaluating the function for 0, so I'm replacing the x with 0. When I do that, I get 2. That means my answer is 0, 2. All right, I want you to try the last two using the same technique we just did. So pause it, try your best. Okay, so you can see if you got it right. So in orange, I evaluated the function for 1. I replaced x with 1. I got 7. So my coordinate point, my ordered pair was 1, 7. And then the last one in purple, I evaluated the function for 2. I replaced the x with 2. My answer was 12, so my ordered pair was 2, 12. So that's what we do when we evaluate a function. We're replacing x with a number, and we're figuring out what we get. We're inputting a number for x, and we're figuring out what we get as our output. And input and output are just ordered pairs. That's how we get the XY coordinate ordered pairs. I know that's a lot. It's putting a lot of stuff together that you talked about in the past. So if you have any questions, let me know. Email me, remind me, do whatever you need to. This is the end. All right, bye.